All right, today we're learning section 4.2, greatest common factor. We should be in our books on page 177. We find greatest common factor using two methods. That's through listing factors and prime factorization. With prime factorization, common factors are important. With common factors, it's a factor that both numbers share, and we use that to group our common factors and find our GCF. So common factors are important. Now in example 1, we're using a choir example. We're actually going to find the GCF using both methods. The first one is listing the factors of each number, which is what we did yesterday in class. So we have our three groups of numbers, 24, 60, and 36. And we basically need to pair these numbers off, numbers that can be multiplied by each other to equal these numbers. And that's what you've been working on there at your seats now. So let's just go ahead and shift gears over to that page. All right, so here we have now our groups of numbers. We're going to list them least to greatest. So we have 24 is going to be, and help me out, 1, 2, 3, 4, 6, 8.
12, 24.
All right, very good. And then for 60, we have
1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60.
all right, awesome, guys. All right, and then for 36,
1, 2, 3, 4, 6, 9, 12, 18, 36.
all right, beautiful. Okay, so now with my listing factors, I'm looking for the largest factor that all three numbers share. It can't just be two of them. It has to be all three numbers. So you have a 2, okay, but is that my greatest common factor? No. You've got a 3, but 4 is bigger. Okay, you've got 6, so we keep going until we find, yes, our 12. Our GCF is 12. That is the largest factor among all three of the numbers. GCF is 12. All right, now this only works when I'm dealing with relatively small numbers, because who would want to list all the factors of 120 and 960? Anybody want to do that? Okay, that's going to be no fun at all. All right, that's going to be no fun at all. So with listing factors, it only works with small numbers. Most of the time, we are going to solve using prime factorization, which is our second method of solving. With prime factorization, let's go back here to our other slide now. With prime factorization, okay, we're going to do, what's your method, your preferred method? You like factor trees or upside down division?
Upside down.
Yeah, upside down division, it leaves a little bit less room for error, so that is the method that I prefer too. So let's go ahead and do upside down division for all three of our numbers. Okay, and then we're going to list off the prime factorization of each number, 24, 60, and 36. This is different than the first method because here we are listing our prime factors. With the other method, we were listing all of our factors, and that's why we could just identify the highest number as our GCF. With prime factorization, it's going to be a little different. All right, so let's go ahead and work through this to list our prime factors. Okay, so now, does your prime factorization match mine? For 24, we should have 3 2s and a 3. For 60, 2 2s, a 3, and a 5. And for 36, 2 2s and 2 3s. Okay, so now I need to pair up my common factors. We talked about common factors a few minutes ago. So a common factor has to be in all three of the numbers to count as a group. So I have a group of 2s, and I'm going to circle them. Do I have another group of 2s?
Yes, ma'am.
I do. Do I have any other common factors?
3.
I have a group of 3s. Okay? But that's it. That's all I have because there's not a 5 in all three numbers or another 2 or another 3. So for each group, I'm going to write it one time in my GCF. So I'm going to write GCF down here equals 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 is 12. Like I said, 9 times out of 10, you're going to use prime factorization to find GCF. Listing factors really is only practical when you're dealing with very small numbers. Most of the time, and especially on the problems that I'll give you on a quiz or a test, prime factorization is going to be the way to go. All right, so with more than 2 numbers, make sure that the factor is in all the numbers to count as a group. All right, now let's work the prime factorization of a couple of more numbers. But before we do that, I want to go over the term called relatively prime. Okay, and I want you to write this down in your notes. 2 numbers are relatively prime if their greatest common factor is 1. We know that every number has a factor of 1, right? Of course, every number has a factor of 1. Well, sometimes 2 numbers, that's their only common factor. They have nothing else in common. They have no other factors in common except the number 1, and that's going to be why the numbers are called relatively prime. All right, so let's do some more factoring, prime factorization to find the GCF. All right, let's do, I'm going to need a little more room than that. Okay, let me come over here to my other slide. Okay, so now I'm going to do the prime factorization of 24 and 45 to find my GCF. You don't necessarily have to write this part in your notes, but I do want you to list off the prime factors. So I'm going to do this kind of quickly. Okay, so list off the prime factors. For 24, it's going to be 3 2s and a 3. And for 45, it's going to be 2 3s and a 5. All right. Now, do I have any common factors here? Do I have any common factors between the 2 numbers?
3.
I have a 3. I have one set of 3s. So what happens if there is only one set of numbers that these 2 numbers have in common? There's only one factor, and that's the number 3. Well, I'm going to write it one time in my GCF. And can I multiply it by anything else? No, so that's my GCF. So anytime you only have one pair of common factors, that number is going to be your GCF. Here's the mistake a lot of people make. They see a set of 3s and they try to do 3 times 3 to get 9. Okay? But that would only be if you had 2 sets of 3s. If you had 2 sets of 3s, then you multiply them. Does that make sense? So for each set, you only write it one time in the GCF. If all you have is 1, that makes the GCF easy. It's 3. Okay? There's no math involved. All right, so let's look at another one. What if we had the numbers 35 and 54? Again, you don't have to do the upside down division part. I just want you writing the prime factors. So we have 5 and 7, 2, 27, and then we're going to have 3 3s, I mean. Okay, so 35, my prime factors are 5 times 7. And for 54, so this part you're writing in your notes. You're writing in your notes. Okay, 2 times 3 times 3 times 3. What are my common factors? Do I have any? Do I have any common factors? There's nothing in common. I have no common factors except my understood 1. So if there's nothing I can pair up, I'm going to say exactly. GCF, you have to have both parts to this to get full credit on your quiz on Monday. Okay? GCF is 1, and I'm going to say relatively prime. You have to say that they're relatively prime. I want you to be able to recognize that if the GCF is 1, the numbers are considered relatively prime. All right, so now one more example. In example 3, I'm going to now be dealing with, and this is similar to our example 3 from yesterday, monomials and the GCF. Remember, monomials are numbers and variables multiplied together. Okay, so let's look at some examples of this. And again, I'm going to have to go over to my other slide so I have a little more room to work. Okay, so I have these two monomials. I have 18 xy squared, and I have 28 x squared y squared. Okay, so the first thing I want to do is the prime factorization of my numbers, 18 and 28. So I'm going to do that off to the side. I'm also doing this on notebook paper so in hopes that you'll see how I want you setting it up on your homework assignment tonight. All right, so 2 goes into 18 9 times, 3 and 3. 2 goes into 28 14 times, 2 and 7.
Are you writing that like right now?
Yeah. Okay, so now here's what I want you to do. List out your prime factors. Okay, 2 times 3 times 3. I'll take a break in just a second to let y'all catch up. And then 2 times 2 times 7. All right, so go ahead and finish that prime factorization and writing out your prime factors. Okay, but now I can't forget about my variables, right? So I need to break those down. Well, which variables do I have? I have x, and I have, all right, so I have xy squared, and I have a x squared y squared. So here's how I want you to do it. I want you to break these down to x times what? Y times y, and x times y times y. You see what we're doing here? We're breaking the numbers or the monomial down into its prime components. And now we can pair up the common factors. So what do I have in common on 18 and 28?
2.
My 2's. Very good. What do I have in common on my variables?
X and Y.
One an x and one y? 2 y's. Okay? So now I come over here to my GCF, and I'm going to keep it expanded for a minute. I'm going to say 2 times x times y times y. Now at this point, I can write my products as a power. So I could say 2xy squared. If you leave it like this, it'll probably just be like -1. Okay, so I do want you to kind of condense it together in the end for your final answer. Okay, so now we're going to come over here to page 178. We're going to do a little bit of classwork. Checkpoint. On page 178. Numbers, what did I say? 7, 8, 11, and 12. Okay? Just working through some of this just to kind of sum things up. What was the GCF of number 7?
11.
Yes, it was 11. What about number 8? 1, relatively prime. Make sure you identify them as relatively prime so you can get full credit. All right, so what can I pair up? What can I pair up on number 11?
X.
I can pair up my 2, my 2, and my x. So in GCF, I say 2 times x. Anything I can simplify? 2 times 2 is 2 to the second power. I'd like you to evaluate the numbers. Since you know what 2 to the second power is, what is it? It would be 4. Now the reason I leave my variables as powers is because I don't know what value the variable would stand for. But if I have numbers multiplied together, I want you to go ahead and multiply them. So you get 4x. So last but not least, help me pair them up. What's it going to be? 2's and y's. Anything else? So GCF is 2y. Okay, you don't even have to multiply anything on that one. There was just one group of numbers and one group of variables. All right, if you understand that, that's everything you need to know for 4.2.